is Roman Nicu, Technical Director for the Mechatronics Innovation Center. We are a company that provides services for medical equipment development. We are certified according to ISO 4845, 13485. Sorry. And I think I will take 5 minutes to talk about our company. Well, our mission is to grow by staying on the cutting edge of innovation, to have the most up-to-date state-of-the-art technology. We provide a full product development, starting from project management, requirement engineering. We have different departments like electronics, mechanics, software, embedded software, procurement, prototyping, and till certification like FDA marking and USA. We were established in 2009. We've had quite a busy, complex history. We were established in 2009 in Iași. In 2018, we came to Iași. We opened the branch here. And I would like to tell you a little bit about our activity in order to avoid talking only in figures. I'd like to tell you about a project that's ongoing in our company for already 5 years, and I think it's two more to work on this. Well, first of all, we think about the issue, the problem. What's the pain? Because in medical industry, the question is a direct one. What's the pain and how we can help the patient solve this issue, avoid the pain? Well, one of the serious issues when a patient is not conscious and on mechanical benches is loss of diaphragm dysfunction, where diaphragm has the same muscle tissue like the heart. So if there is no caution in that sense, they would lose the tissue mass. So if in 18 hours the diaphragm is not used, they might lose up to 50% of the diaphragm muscle mass. Well, that's a big issue for the doctors because the patient is in coma, then they need to work to bring the patient to recover, and this would take up to 1 week, the entire procedure. 1 day of intensive care in America, it's $7,000 per patient per week. Well, the brilliant idea was to understand how we can train to work with the patient whilst they are unconscious and to help them not to lose the muscular mass. Everybody has seen the advertising on the electrostimulators that are attached to the tummy, and there's this in six-pack. Well, the idea was to do this in a non-invasive way. The possible solution was to generate a magnetic wave and to induce to the patient the desire to breathe by themselves. Well, we've done this. You can see in the image on the right 2 coils on the neck of the patient. 2 magnetic waves of about 5 Tesla each are generated, and the biggest issue with this device is to synchronize with the breath flow of the patient. Because imagine we do an experiment, we try to exhale, then to inhale. This is not comfortable. Well, we try to do this synchronizing with the breathing of the patient. Basically, it's a simple device. A student might do this in half a year. We're working on this for 5 years, actually, for 4 years. Why? Because we have the following paradigm. what actually happens with the patient if our device does not function correctly. The worst response is that the patient dies. Well, we've been a patient once in our lifetime at least, and at least we've been measured the blood pressure and the temperature taken with some device. Well, imagine that you go to the doctor and you know that this device was not tested in under all the circumstances, and it's possible that one in a million cases it works not appropriately and you have a consequence in this regard. How would you feel about this? Not very good. Well, that's why we test and again test the devices. We are now at the clinical studies test, and this takes up to 1.5 years. And we need to prove that during this clinical test that this device does not harm the patient. This is an innovative device equipment. This means that the certification or accreditation body do not know how to look at us. Is this a good or a bad option? They just suppose. Well, and in that case, we received the response to our request for certification, a response of 73 pages, all with questions. What happens if? What happens if? And for 1.5 years, we have this communication with the FDA from America to answer to the question: what happens if this happens? Well, yes, but if happens the other situation, so this is a 1.5 year process. That's one of the medical challenges and one of the points that does not allow us to be super innovative, like for example with the cell phones, because in that sector every gadget or every device could be in a half year on the market. In our case, this takes years and years because patient safety and security and is important. The risk for the patient should be the lowest. That's all. Thank you very much. Very interesting introduction from my point of view. We will continue with presentation from companies. Next, we invite Mr. Roman, working as a team leader in AROBS group, to come to the presentation. We've said before that AROBS has good experience in automotive sector, but we will see that our colleagues have developed skills in biomedical engineering. And in that sense, we would like to ask Mr. Roman to share their experience in this regard. Good morning. Well, we've mentioned before about our Arabs company. Well, I will talk a little about this. It's a big company, the largest technological company in Bucharest Stock Exchange. We work with companies from all across the world. We are European by birth, international by culture. Sorry, we have partners all across the world, different locations, and in order to get to the main element that we call the life sciences, we've previously worked with companies from pharmaceutical sector to help them better process their clinical trials data. We've worked quite a lot with companies developing medical devices. We've worked also with laboratories to help improve their processes, databases, and so on. But taken into account the specific of the conference and the topic we are addressing, I will talk about medical devices and how did we work together with our clients for the development, what have we done, what we keep doing. But I can tell you that indeed, well, I'll talk not so much technical in technical terms because my colleagues who talked about the automotive sector covered very well the technical aspects, and our technical details are similar with those, but there are also some differences. For example, our first big collaboration with the medical devices manufacturer was 15 years ago. and they had their product on the market for 15 years. And at that moment, exactly because well, they used tested technologies, proven that they dysfunction, but the costs to update, to renovate were expensive. They could not, cannot take technology from the market because everything they take from the market should be certified, and which is expensive. So they start to feel uncomfortable with different elements. For example, a processor that works for 20 years, but they do not find the spare pieces or spare parts, or they do not find the other components, or a 20 years old processor could be hacked very well. Not too much to work on the cybersecurity. That moment in time they didn't know very much about this, but now it's well known. And after they were showed on YouTube in front of the whole world that somebody from the hospital car park could connect to the system in the hospital and order an infusion, they understood that that's not a joke and something had to be done about us. At that moment, we were known for doing embedded operation systems, and they contacted us to install an embedded operation system on our product. They used a simple processor, but we applied the more complex one. We've worked on the UI part, response to inputs, and in that way they managed to extend 10 years more the life of the product, lifespan of the product. And at the same time they kept us to be the suppliers in terms of developing a new generation platform. And I'd like to go to that moment. We work with them for already we've been working with them for already 6 years, and now they received the approval from FDA. And these devices would be in the hospital. A new type of infusion pumps with touch screen, which did not exist before. Well, they did this. This works with Linux. It's a 1 GHz based system, 1 giga RAM. There's a lot of technology involved, and they wanted to bring as much modern technology as possible in that system because they want to be 20 years more on the market. And to be able to update this remotely, to have everything secured, now they have separate chips for engines, for interface areas, for communications. And if we talk about trusted area, partitions are encrypted, and so on and so forth. So they looked at all the precaution elements and tried to develop a product that is as feature proof as possible. One of the differences compared to automotive, besides the similarities, yes, this is a process. There are risks for the patients that we need to address. There's a lot of testing, and alongside with the development of the product, we develop a lot of tools and softwares. And for example, we have testing tools that need to automatically test the entire system to function overnight, to make sure that what we put today on the branch would not disturb products that worked yesterday. But we would imply some more esoteric elements. For example, for translator, we do a simulation of all the screens, all the tests, which are sent to an interpreter, translator, so that they can edit visually the text to translate in English, French, or any other languages, and to see live how the screens of the devices will look like. This saves a lot of time for the translator. Otherwise, the alternative was to give the translator a 1,000 pages Excel sheet to get the translation and to see, for example, that text exceeds in format or length, because English is a brief language, but in other languages we might exceed, go beyond all the limits, all the squares or the limits. So we managed to have a good flow of the work with the translators, and we also managed to help them install their own large language model server, because given that we don't have the same standards as in automotive, they all believe that they have secret service-related secrets, and they don't want to have this connected with ChatGPT, for example. So in that moment, we help to install their own internal servers that would work chat with ChatGPT with a lot of related apps, verification modules for an engineer to do the review. They will be able to watch what the realization the results are, but they could not avoid the simple errors. And in that sense, we might give a solution to let you look at them. And there's many other issues. We talk about documents in the medical sector. That's a lot of, it's complicated, it's complex, and it's quite difficult to find relevant documents. We use tried and tested technology, but at the same time, I can see a lot of benefits of the innovation that's using here. We also work with another company, quite an important project to do automated system for detection systems. I could not give you a name. Maybe you've heard about them because they've recently introduced a device quite recently in pandemic period to detect COVID virus at home, basically. And another large company switched to big lab equipment where they use some transparent vessels and some cams. They would look at the cells of the patient in order to identify the virus. Well, these are approved elements, but I could tell you more about the infusion related devices where I work directly on the development. We also have mobile apps in the sector. I really hope I was quite brief, but I really hope also that I've raised your interest. Thank you very much. Thank you very much, Mr. Andrei, for presenting AROBS company and for presenting the activity in terms of biomedical engineering. Next, I want to invite the academia to present. We'll have Dr. Ciorba from Faculty of Computer Science, Informatics, and Microelectronics from Technical University. We know that university is an important pillar in this technical field, and our university is the only one educating uh, future employees in this sector. I'd like to ask you, what are the updates in this sector, and what should we do in order to make biomedical engineering more popular in this sector? Thank you very much. We do a lot of presentation during the year, so I will try to be quite brief and specific. Yes, that's true that Technical University in Moldova is the only institution in Moldova, higher education institution, where we have this specialization as academic program, which is accredited, certified. We have all the documents in place for the biomedical engineering. The director from Mechatronics Center said that innovation in biomedical engineering are hardly put in implementation. But that's true because when we think about innovation, these are some improvising elements related to some specific issues. And before going to the engineering stage, there are some other steps. So I think it's natural for this to be a process that's educated, that is developed in the young generation, because quite often, if the improvisations are not tested continuously, these are punishable. They might lead to serious consequences, even this might kill. We've talked about this element from inter or cross-disciplinary perspective. We have several components involved. I would not say that that's a dual component, but we have this component covered also by the university, medical university from Moldova. We have one lecturer, one professor from university, that professors that run those medical institutes, and they bring those innovations for our biomedical engineers. That's indeed a program that is more and more requested from the market. I think we have 20 more actors going on the market, 20 more positions going on the market. The question is that these people, there's qualified staff is enough, or we need to increase slightly the number. We have two faculties which are more or less related to this sector, the digital sector. I will not say ICT because we have also the electronics components. We have electronics and telecoms. We have Madam Sava here, and we have a total of 3,500 students. We have also software-related decisions in this sector, and which is the most popular now. All the presentations I've seen so far are actually taught in the traditional sector related to calculations, the water for agile, everything we learn in the traditional sector. But there are some elements we don't have, and we are ready to take this over, and the market is ready to absorb this. This culture of switching to the embedded sector should be slightly and step by step not included, taken over, because we focus on electronics and bioengineering. We will suffer on software development. There's still room for improvement. The main issue is to attract the people and to maintain them, because despite all the elements, the components we have, not all the people that we have, they slightly change their path and focus on software more than biomedical engineering. Again, we don't need separated approval from the ministry. We are not limited in this sense. We have, in terms of content, flexibility to change the laboratory topics or specificities, specializations. But maybe we might also have some boot camps to test for 2-3 days to understand if young people react to such technologies, and boot camps of a few months to understand if it works for long term in such a format. We have such experience, and we have companies that give such trainings. In our teachers are trained in order to be able to deliver these trainings. Next, in the future, we will support biomedical engineering as a program, because we want it to be an education academic program that has also master's and PhD degree, to have the full cycle. But we would like also to be as relevant as possible for the market. And in this context, I want to thank everybody, the panelists, those in the room, for being here and for helping us. Thank you very much, Mr. Ciorba, for giving this speech, and we are grateful for the support of Technical University in the development of bioengineering sector in Moldova. And now we invite Mr. Artur Burdujan to talk about the activity of the company he is working in, GBG MLD. Hope I pronounce it correctly. And I would like to ask him kindly to tell about the strategic aspects in its field.
Mulțumesc pentru invitație.
Good afternoon, everyone. Thank you for the invitation. We are GBG MLD SRL. We are the distributor for medical equipment from lab, angiographs, resonance, CTs, USG, and so on. In terms of studies, I will start by saying that I was a student sometime, and talking to the students that are employed in our company. So we see the same issues, or maybe the issues is not the best word. In university, we are taught that we are prepared for the job. Actually, it's just a bit from what for the rest of 69%, we need a lifetime to study in order to become high-ranking bioengineer. And 1% we have for the errors that we have throughout our life or while we are studying as engineer. And I would like to address or speak to the students who are now studying this area or would like to study bioengineering. And they are saying we don't learn so much about microelectronics, about bioengineering, or about anatomy with applications in bioelectronics. We have a lot of classes such as higher mathematics. Why do we need all these courses if in practice nobody will ask who was a certain philosopher? This is needed so that the students have an analytical thinking. Without analytical thinking, we cannot call ourselves engineers. We shouldn't only be present in two areas. We need to think analytically and look at problems from different angles, because in most cases, the engineer from the hospital or from the private sector and is discussing with a doctor, saying that the device is not working. When you are just listening to the sounds, you need to figure out how to help them with the device so that in the end we save another patient, another life. This is why I urge you to continue studying. Do it all the time. It doesn't matter what you need to study. If it's required to study philosophy, do it, because the analytical thinking is the only tool that the engineer has, and this is what determines how good the person will be in their job. And one of the drawbacks after finishing our studies is that we don't know how to behave in our first job interview. We don't know how to introduce ourselves. We don't know how to present what we can do in practice, because we have the theoretical knowledge from university, but we don't know how to explain to that doctor, to that employer, how can we solve a certain problem so that they understand, so that this is not Chinese for them. Because most of the times when you go to an intervention as an engineer, it happens that people tell you about the problem, you start discussing about microengineering, and when you say that you need to change safety on a plate, in the end you have a device that cannot be considered safe for the patient. That's why it's very complicated, and it takes a lot of time for an engineer to be trained by us, those who have already been through this, so that the person discusses in an appropriate manner with the client, so that they don't think that the device that you have fixed is not safe. Where can we get employed? There are two important parts. You can work in the private sector as a specialized engineer. This means that you are an engineer or a creator of a device, if this is possible. If not, you are a specialized engineer. This means that you are in a private institution that specializes you in a certain field, such as radiology, depending on the profile of the company, or you become an engineer in a hospital. In a hospital, there are many devices. There's a lot to learn, but there's no, you don't have that intellectual growth aspect. You have a device, and if you can fix it, then it's okay. If not, you send it to the repair center. And you don't grow a lot, you don't learn many things related to engineering. There are single-use consumables. You need to purchase them annually. Lately, this is done by the engineer and not by the nurses or the head of unit. This is done by the engineers. And there's a lot related to prices, procurement. This is something that the engineer does and not the part of the institution that it relates to finances. So you need to persevere, you need to show interest. It's complicated, and you depend on the local market. If you want to be an engineer in linear accelerators, let's be realistic. How many do we have on our market? If there's two of them, you don't have any chances to become a specialist. So you can be an engineer, the person that just calls and explains the problem of the doctor to the specialist. If after a while working as an engineer, you start having fears because you are in the ICU unit, or you are repairing a device and then the patient dies. Many people lose interest. They consider this is not normal. They are not prepared for such situations, and they leave the field for good. They have good chances of getting a job in a different area because you have the possibility to become an engineer in electronic plates, in bore plate. They can become engineers, designers, for example, for the design of the ICU, how the communication should be laid out. So we have engineers that have crossed to this domain. Some engineers go to the application domain. They teach the doctors how to use properly the medical devices. So they mostly study anatomy, the medical application part, and they are together with the doctor and the patients all the time. And this is welcome now. We don't have that many such specialists in Moldova. Many doctors don't want to switch from being doctors to being such engineers. Some can go to the part of microelectronics engineering. For those who want to switch from bioengineering to IT engineering, the market is large because we have what is related to the flow of data, flow of patient, where the data is stored, and so on. There's not that many that much software. There are not many specialists that can use such software. The, so there were a lot of attempts to create new software, but the issue is the same. The volume of data is very high, so there's a need for servers and a lot of resources for IT engineers so that it is comfortable for the patients, for the doctors, and so on, so that they can understand when the last lab tests were done, and so on. Thank you for your intervention that covered a wide range of topics. You somehow told us where specialists in medical engineering could work, but I would like to ask a question on the new technologies and more exactly on the integration of AI in existing medical systems. I would like to ask what are the challenges for integrating AI in modern biomedical devices. Mr. Roman, Mr. Nicu. This is indeed one of the great challenges we are facing today because the first question in healthcare is what happens if my device is not working properly. Let's imagine that we have AI that reads an image and tells us that there's a probability that the patient has a tumor. We have taught the AI and so on. We do an CT or an MRI, and the AI says the patient has a brain tumor. We open the brain, we see that there's no tumor. The question is, how would you feel as a patient if this happened? What are the risks? Of course, the patient could die because any brain surgery is risky. And then we have the question, how do I, as a developer, guarantee that the AI indeed minimizes the risks? Indeed, the AI does whatever they want. The AI taught the AI something, then they learn by themselves and gives suggestions. How do I guarantee that the AI stays stable throughout the life cycle of my product? We could ask AI to create an algorithm. Then we have a part of static code that is not taught, and you can test it traditionally. And the AI is just a tool. And this is okay as a temporary solution, but still the question is, how do we guarantee the stability of AI? We don't know. There's a series of draft laws, not only in the medical field, but in general in the European legislation. But this is the initial phase, and it is not mandatory. And this is a problem that is consistent because we are offering consultancy to startups, and we have several requests from startups that took AI, taught it to analyze different data sets, and now they come to us and ask, how do we certify it? How do we turn an interesting product into a medical one? And the question is an open one. Thank you, Mr. Roman. Mr. Andrei? Yes, this is correct. What I could add from our experience with our customers is something that I mentioned earlier in my presentation. They are interested in using AI. They are trying to use it isolated from the rest of the market because they don't want their prompts and conversation to become part of the conversations of the whole world. It would help them with bureaucracy and paperwork, but everything that AI does should be checked. They have a culture of checking the work of a human, and the same idea should be used for checking the outputs of AI. I think this is the approach so far. Of course, it wouldn't be bad if we had a legal framework for this, but until then, we should have experiments also. Mr. Dean, I would like to thank Artur and for the fact that he said we are only preparing people at 30% for the labor market. People say usually that we don't prepare them at all. And I would like to thank GBG for the fact that they stand by us. We can not guarantee that you will have 100% preparedness. Not even you won't be prepared 100% even after you work 5 years in a company. Next year, the technical university will change the education plans. And there's something that we cannot do. If for software we can do digital modeling, even in the cloud, the part related to medical bioengineering is very costly. And the engineering training has been underfinanced. We are very happy that you have this equipment that you are promoting, and maybe the students will not think about moving to pushing buttons on the screen, as we say. Regarding AI, I'm sure it will be regulated, especially in healthcare, because there we have the ethics commission, and if you have a PhD thesis that doesn't go past the ethics commission, it will not be accepted. We have already theses that analyze images with lung diseases, and it was very simple to determine. This is something that I didn't know. It is easy to determine based on images if this is caused by a virus or a bacteria. It figures out that it leaves different scars. So this is a simple solution: analyze images or train a machine. You teach it and it takes different aspects. The task of the student came from an employer in imagery, and this was during the COVID period when they had to analyze a large number of images. So this should come from bottom up in terms of regulations. In the university, we consider that this area is like cybersecurity. This is a cross-cutting component. We have a cross-cutting course in cybersecurity and a course in AI that is for everyone. So this way we can guide people, but in the end, the doctor is the one taking the decision, regardless how advanced the technology is or the AI. Mr. Burdujan, regarding AI, as I am specialized in ultrasonography, AI. From what I remember, AI was introduced in England in an X-ray imagery lab. The difference from the doctor that analyzes this, so the error rate is less than for a person that has a 20% error rate for the same images. The AI coming to healthcare in ultrasonography is meant to help the doctor, not create problems. So, for example, we have an investigation for the thyroid, and we move device for a different organ. We have different color maps in order to have a better resolution for the blood vessels. This does not create problems for the doctor. It helps the doctor to use the device easier and to have a response for the patient that comes faster. Also, the AI helps with automatic measurements. This is something that the doctor doesn't accept that easily, because the doctor would like to have this automatic measurements, but this would involve that the doctor says when it has to stop and how to do the calculation. The doctor is still needed. The doctor will be there to operate the tool, and the doctor needs to allow us to present the product using AI to them. Based on our resources in ultrasonography, we have 29 types of automatizations. This is a lot because 2 years ago we only have 2, 3 such automatizations. It was for images, for contrast, depth, the type, and it took into account what type of room you are in, if it is obscure, semi-obscure, and so on. This is very important for USG, and this is better for the eye of the doctor, because whether we like it or not, the eyes of the doctors are the parts that are used at maximum. So indeed, without the human factor, we cannot do anything in society, although we have high technological advance. Dear participants, thank you for the topics. Mr. Andrei, yes, I would like to mention another thing. If you mentioned the fact that we move on from being students to being engineers, and we have faced this issue, combined with the fact that the client wants to hire people with experience, and we in Bucharest, we have for several years an interesting program for students, and this is also interesting for our customer. This is an internship program, and we have final year students. We give them some homework. We see how interested they are for in tools. This is not related directly to software for the device, but we can bring students from the software area because this is more applied for tools, and we can see how interested they are. They can see that we're not only talking about embedded, we have a lot of software in the area of medical devices. And at the end of the internship, we can select 1 or 2 of them to become our colleagues when they get their degree. We have been doing this for 5 years every year, and all engineers that have joined us this way have stayed in the company and have not left it. Thank you very much. We appreciate the contribution of AROBS in the development of the education system. We also have other companies that, together with the university, the technical university, have developed courses for the training of teaching staff. Please applaud our engineers who are making our lives easier and safer when we go to the doctor.